So let's get started. Thanks everyone for coming. This is the keys to iOS security. We'll be covering the basics of security on iOS from the keychain to hashing and biometrics. My name is Ryan Ackermann. I'm an iOS developer on the uversion Bible app. So let's start with why security is important on iOS. So iOS stores a lot of personal data on your device. It's more than just a computer you carry around with. It is a collection of all important information that you might take. So, for example, photos, you might take a picture of loved ones that you might not want public, or photos of receipts or documentation that you might not want to be viewed by just anyone. That kind of correlates to messages as well, just communicating back and forth with loved ones or for business purposes. That's another piece of secure data, as well as your health information. So your phone is keeping track of a lot of information about your health, so steps and maybe your health records. You can store a lot of your information in the health app using HealthKit. So who are the threats to iOS applications? So maybe obvious, but criminals that would want to just get after your data, kind of break into your application and steal information from your application. Business competitors, they might want to steal ideas that you may take down in a note app, or just your secret sauce to your applications. Service providers, so like your internet service provider might want to just track you and try to figure out what you're doing using the internet from them. And they may want to sell that information to an ad agency, for example. And another threat is your friends or family. So if you're trying to keep information private from friends or family, so for example, birthday presents, you might not want people to just, get into wherever you're keeping that information. Maybe that be Amazon, your Amazon purchase history, that you don't want to see their present before they actually receive it. So bad security hurts user trust. Kind of obvious, but so one example of how that could hurt someone, so financial loss. If your application is hacked and maybe payment information that is stored in your app gets retrieved by an attacker, that would be pretty bad to how the user perceives your app. So leaked passwords is another example. If an attacker gets access to the passwords that your users enter in your app, that could be bad for numerous reasons, and one might be a user might use the same password for your app as they may do their bank account, and that would be pretty terrible for your application to leak that password for that example. And another thing is personal surveillance. So if your app is hacked and someone is just able to monitor your activity in that app, and that depends on what your app does. So if your app is an activity app, they might be able to just see like where you're moving around as you go about your day. And so that would be something that, if that was hacked, a user would not really trust your application. They might move somewhere else. So this is a tweet that happened recently. I think it was just last week. This is the TMobile Austria account. They tweeted basically back and forth with another security researcher. And the security researcher basically found out that the T-Mobile in Austria was actually storing users' passwords in plain text. And the security volunteer was going back and forth to them saying how they basically have amazingly good security, so they shouldn't worry about it. And basically, it's a pretty good thread to read, and you can find a link to that later. So what does security look like on iOS? So there's a couple types of data, just reiterating, covered this before, but so user data, anything a user might enter into your application, such as photos, such as Instagram, potentially, or notes. And then payment information, if your app is an e-commerce app, attackers that would be able to access that would obviously be able to potentially steal money from your users. And then login credentials, like I said before, passwords are probably shared between many services for the common user. So let's look at how to implement security in iOS. So our example will be storing user credentials, so an email and password. This is a pretty standard use case. So user defaults, this is a way that you can store basically information across app launches. It's a pretty common way to store information, so let's take a look at how we do that. So you can see here that we're going to declare an enum to just specify some keys that we'll use in user defaults, and then we're going to go through and set the email for the key email, the password for the key password, synchronize that, and then at the end we're just going to post a notification so the rest of our app knows that the user authentication state has changed and that we should update other parts of our app accordingly. So don't do that. That was not a code example. That was how to not do security. So yeah, again, want to iterate, don't do that. So why is that bad? Why is storing plain text passwords in user defaults not a good idea? So passwords stored in user defaults can be read by third-party libraries. So if you're including potentially a third-party add SDK, they can read user default values. They can basically dump all the keys you're using and then read all those values. And so if you're storing passwords in user defaults, then a library could potentially mine all of your users' information if it's not a very trusted library. Another example is unencrypted device backup. So if you're backing up either to iCloud unencryptedly, or to iTunes, you can actually uncheck the box to have your backup not be encrypted. An attacker could break into that and then view your user default values you're storing there. And then another example this is pretty easy to do. You can just download a program onto your computer, either Windows or Mac, called iExplorer, and you can actually read values that are stored in apps in this way pretty easily. In one example of this, actually, a few years ago, I was playing a game called Hill Climb Racer, and they're actually storing they were storing their high score in user defaults. So I was actually able to use iExplorer to just go in there and give myself super high score, show all my friends, and basically make it seem like I was just the best at this game, which I wasn't. And then it was actually more impressive when I told them how I did it than actually getting that high score. So let's look at how to basically store not just the plain text the user is entering. So the only thing that's different here is we're going to encode the password using the base64 encoding in iOS. So we're just converting the password, the plain string, to data, and then we're just going to create a base64 encoded string of that. And what that might look like is the input, if my password was my hard password, some numbers because security. The output might look like something like that below. So encoding is not encryption. Just want to make that clear as well. Encoding is actually taking data and transforming it so that other systems can actually read it. So if you're trying to store a password that you don't want another system to read, you don't want to use encoding because that's actually meant to be reversed by another system. And the only other difference between encryption versus encoding is just you want to keep that piece of data you're transforming and you want to keep it secret from others. So that's the key point to note there. So Apple's Keychain, this is pretty much the de facto way to store private information, sensitive information to a user. It is Apple's specialized database where you can store stuff with security in mind. They built it specifically for this type of a use case. So how do we use it? So this is an example. This method might be called, this login user method might be called after a successful network request comes back. So this email and password is validified with our backend. Then basically we're going to use a keychain wrapper here and create an item and pass in the service name, which can be anything for your application. So for this example, it might be the app's name. Then you create that with the account that you want to store the password for. Then using a try-catch statement, you basically save it to the keychain and then again post that notification and then handle the error. Probably not just by printing it, you probably want to handle that better. So this keychain password item is a wrapper around the keychain. It's not the actual keychain Apple provides, but this keychain password item is actually part of a sample project that Apple released. So this is kind of their wrapper around the keychain. And why would we want to even use a wrapper for the keychain in Swift? That's because the keychain is actually a C API that is not very nice to deal with in Swift. So we want to use a wrapper to basically make interacting with the keychain a lot nicer and friendly to use. So this is better than the just storing it in plain text in the user defaults, but we're almost there. So let's actually cover why that's not the full example we want to work with. So Apple's keychain can be compromised, and if you head to this GitHub link, you can actually download once your device is jailbroken, you can download this piece of software and install it on your device, and then you can dump all values in the keychain. So if you're just going to take the user's password and store it directly in the keychain, that is not the best practice of what you can do. Because if, for some reason, a user comes across your device, and actually just recently I saw, and there's probably more ways to do this, but just recently there is a device that you can actually crack the 6-digit password code on iOS within a few days, actually. So if a user just steals your phone on the subway or something, or in the airport, they can pretty much compromise all of your information stored in the keychain, so probably all apps if they're not using the best practices. So what is that best practice? So instead of storing the direct password that the user is entering into your app, we're actually going to create a hash from the email and password. So the first couple lines here, the count and data, we're just going to create a securely random value. And so this is just using the security framework. And this is a good example of interacting with the C API in Swift. It's kind of nasty, the whole ordeal of just basically mutating that data object inside of the secure random copy bytes function. But that basically generates a random value that we're going to create a base64 encoded string from, and we're going to call that our salt. And we're going to use that in an array of components that we will create the hash from. So the email, salt, and password will be used with a SHA-256 hashing algorithm to create basically the hash that we want to store. And so that piece that I covered before, the randomization of creating a securely random, a cryptographically secure random number, this is something that you'd want to use if you're going to be creating salts that you want to keep random and not the same every single time. And then the other piece at the very end there, the SHA-256 extension on string, is actually part of CryptoSwift. And CryptoSwift is a very well-known, sought-after library of cryptographic algorithms in Swift. And the reason why you want to use something like CryptoSwift is because you don't really want to try, unless you're a very advanced security researcher, rolling your own crypto. You'd want to use something that is open source, something that is really heavily peer-reviewed. So this is a good example of that. And there's a couple others, but CryptoSwift is the one that I used for this talk. And then so using that hash, instead of storing that password, we're just going to create a hash using that function. And instead of storing the password, we're just going to store that hash. And so this is an example of what that SHA-256 hash would look like if I created an input with my email with randomized salt, the base64 encoded version of that random number, and then a password. And then the output would, it's kind of hard to tell as a human that value compared to the other base64 encoded value. Why are those two different? But cryptographically speaking, this is way harder to crack than the other one. And so what did I mean before when I said salt? What is a salt? It's not actually like salt from a salt shaker. It's basically a way to create the value that you actually want to store in the hash. And it's a defense against a pre-computed dictionary attack, which is just a way of hacking a hash value. So what is a pre-computed dictionary attack? So one example of that is a rainbow table attack. And what this is basically on the left here, we have plain text versions of passwords users might use. So 1, 2, 3, 4, 5, 6, pretty simple password. And then if we just were going to hash that password like that a user would provide, and we just stored that hash, then using this rainbow table attack, a hacker would basically take a bunch of pre-existing passwords that somebody might use, like 1, 2, 3, 4, 5, 6, password, baseball, and then they create a hash, and they'd be able to basically reverse what that password is if they cracked the keychain or cracked user defaults, which again shouldn't use, and they saw that this was a value, they could input that value into the rainbow table and thus reverse engineer that password. So one more thing I want to cover is local authentication. This is new on the newer iOS devices, so Touch ID and Face ID. This is in a way to request that a user would basically give their consent before accessing sensitive data instead of just manually entering a password every single time. And new in iOS 11 with the iPhone 10, we have an enum value that we can actually traverse over and see if there's actually a type of biometry we can use. So either Face ID, Touch ID, or if it's an older device or an old iPad or something, there wouldn't be any. And so this looks like, these are a couple examples. So 1Password and Robinhood, they're, 1Password stores passwords, obviously, and Robinhood stores stock information. So both of these apps are a good example of why they use local authentication to basically not have the user type in their passcode every single time, because their apps, they probably want to, as soon as you exit out to the home screen, they want to lock you out of the app, kind of sign you out. So then if you're resuming the app, then they want to make sure this is you actually using your app instead of somebody else just picking up your phone. And so how do you use local authentication? You first define a context and a reason, and you choose a policy. And this is just a wrapper function just to easily access just by looking at a success value afterward. Then you can use that context to see if you can actually evaluate with a given policy. And so basically what that means is, has the user actually enrolled Touch ID or Face ID? Some people might just, for example, like on an iPad you just want to test with, you might just disable Touch ID because it's easier that way to use amongst a team. So you basically check and see if you can actually evaluate before, and then you actually go through, evaluate that policy, and give it a reason. And then if it's successful, you can basically call the main queue and determine if it was a success or not. Basically, if their fingerprint was successful or if their face was the right face. And then this is just a simple example of how to use that. And if you want to use something like this, you want to make sure that you actually have stored information, so a user has actually logged into your app before. This isn't the first time, because that doesn't make sense to use local authentication if there's no stored information that you're trying to access. And then if you check and see that the biometrics, if that check was successful, then you can update UI, log them in. If not, then you can bump them to an actual passcode screen. So let's just cover a demo really quick. I think may have to do something a little bit different here. I'm just going to mirror the screen really quick. Sorry about that. Here we go. Okay. So we're just going to show an example on my device of the sample project that I made for this talk. So it's just called Avocado. And basically it shows how to store login information in an app. See if I can make this window a little bit bigger. So it's a very simple app, standard. You can just type in an email address, and there's no validation here. It's just, you can enter anything and then any password. And then it stores that information and allows you to see an avocado, kind of just simulating that you're going to store sensitive information. So if you don't want people to see your avocado, that's the idea behind this app. So kind of like a bank app. If you close the app and then resume, you're actually prompted to do Face ID instead of entering your passcode. So if I show my face, then I can see my avocado. And this test app, you can just double tap the avocado and it clears all the information out again. So have Xcode open somewhere. Yeah, so this app just covers basically using CryptoSwift, local authentication, to get the input from the couple fields and then attempt that login from the two text fields that I have in the app. And then the attempt login is something similar to what I was showing in the talk, in the slides. It just gets the email and the password from inputs and makes sure that they're actually values and not empty strings. and then does that login function that we covered before, where we're just storing the hash instead of the plain input from the user, and then updates the UI respectively. So this sample project is available on GitHub if you'd like to check out an example of this. And we'll just switch back over to the slides really quick. So there's a couple links to check out. I actually wrote a tutorial on raywenderlich.com covering security, keychain, and hashing. I don't cover local authentication, but there is another tutorial on that if that's more what you're interested in. I do cover a little bit more hashing in this tutorial, so if you'd like to check out more, then you can look at that. I also have a developer video that is interesting to check out if you're looking to learn more about security on iOS. It's just a developer video from last year. And then there is the Apple security documentation that you can check out and just read up on everything they have, all the APIs that they have made for security purposes. And then if you'd like to get in touch with me, you can visit my website. You can check out the example project on my GitHub page. And these slides will actually be available later today at speakerdeck.com if you'd like to check out any other links that you saw in this talk. Or follow me on Twitter. I do like to tweet some stuff related to iOS development, so those are the ways you can get in touch with me. So thanks for your time. If you have any questions, I could take them now.